I'm Jahnavi from BTech second year of ECE branch, B section. Now we are discussing about probability distribution function. We are represented probability distribution function with capital PDF. First, we have to see definition of probability distribution function. Probability distribution function shows how the probabilities and possibilities of a random variable. Probabilities are distributed values of random variable. In random variable, how the probabilities are distributed is called probability distribution function. Probability that the random variable takes a value. Probability of random variable less than or equal to small x. Mathematically, we can represent it as fx of capital Fx of x equal to p of x less than or equal to x, where capital X is a random variable, small x is real number, x of x equal to probability that x is less than or equal to x. Why is BDF used? To understand probabilistic behavior of random variables. How means how the probabilities of random variable are distributed. It helps to calculate cumulative probabilities. Probability distribution function is also called as cumulative distribution function, CDF. We use it to analyzing probability in real-world problems like tossing coins, games, measurements, etc., where PDF is used in probability theory and stochastic engineering for analyzing signal behavior. How the signals are analyzing. It is also used in PDF. In this also used in PDF. Data science used in real life situations like number of bets in coin tossing, number of defective items in bag, measuring continuous quantities like height, temperature, etc. In these, we are used in PDF. What do we calculate using PDF? We calculate using PDF is cumulative probability up to a certain value. We have to calculate cumulative probability using PDF. Probability of ranges likely for occurrence of specific outcomes. Distribution functions. Discrete random variable. A discrete random variable is a variable that takes specific. Discrete random variable takes specific uncountable values like 0, 1, 2, and so on. Number of heads when tossing 3 coins means 8. 3 coins means number of students present in a class. These are the examples of discrete random variable. What is distribution function? Fx of x. The distribution function Fx of x is the cumulative sum of all probabilities x up to value x. Since x is discrete, Fx of x takes the form of a staircase and increase in steps. The height of each step is equal to the probability of x at that value. by using what this probability distribution function, we have to calculate cumulative sum of all probabilities and how the probabilities are distributed in a random variable. This is about discrete random variable mathematical form of the distribution function. If the possible values of x are x1, x2, x3, x is a random variable, and in that random variable x1, x2, and so on xn are the events, the function is written as fx of x. This is the formula for discrete PDF x of x equal sigma I equal to 1 to p of xi derivative of x minus xi, where p of xi equal to probability that x equal to xi. P of x minus xi is unit step function. What is the unit step function u of x? What is unit? One if x greater than or equal to 0, 0 if x less than 0. This is the mathematical form of distribution function. Example, tossing 3 coins. Let's say we toss 3 fair coins. The prime variable x is the number of heads. Let the values of x be 0, x1 equal to 0, 1, 2, 3, 4, 3, 5. P of x1 equal to P of 0, that equal to 1 by 8. So when we toss 3 coins, probability equal to number of favorable outcomes by total number of P of x2 equal to probability of 1, 3 by 8, P of x3 equal to probability of 2, 3 by 8, to probability of 1 by 8. Then fx of x, we know that formula of probability distribution function, P of x1 into P of x minus x1 plus P of x into P of x minus x2 plus P of x3 into P of x minus x3 plus P of x4 into P of x minus x4. Substitute the values. P of x1 means 1 by 8, P of x2 means 3 by 8, P of x3 means 3 by 8, P of x4 means 1 by 8. This is the distribution function. This is x. It's a number of x. This 1, 0, 3, 4. This is the values we get 0, 0.0, 0, 0.1, 0, 0.5, 0.6. We are right like that. This is the fixed x probability distribution function, and the graph is increasing like staircase. This is the distribution function for tossing 3 coins. Next, if x is continuous, previously using discrete random variable. If x is continuous random variable, the distribution of x is the integration of all continuous probabilities of x up to the value of x. Definition of distribution function. Let fx of x be probability function of x continues when variable by the distribution function of x denoted by fx of x is capital X of x distribution function equal to integral minus infinity to x fx of t dt. This is the formula for continuous probability distribution function. Next, this is the example for continuous probability distribution function where x of x equal to 1 by 12 for 0 less than x less than 12, x less than or equal to 12. This means that the probability is uniformly distributed between 0 and 12. Then the distribution function fx of x becomes x of x equal to, you know that formula of continuous distribution function, integral minus infinity to x fx of t dt or to integral minus infinity to x 1 by 12 dt. We have f of fx of x 1 by 12. Now for 0 less than or equal to x less than or equal to 12, it's equal to x by 12. For x greater than 12, x of x is equal to 1. This is the graph for probability distribution function. Probability distribution function. And this is density function. This is capital Fx of x. And this is density function Fx of x. Constant accelerator line at 1 by 12 from x equal to 0 to 12. This is x equal to 0 to 12. This is fx of x, probability density function. This is probability distribution function. This is probability distribution function. Distribution function fx of x lies between staircase increasing limit 0 to 1 between x equal to 0 and x equal to 12. After x equal to 12, the function stays at 1, meaning total probabilities is increases like this. This is about probability distribution function.